What's up, guys? Welcome to the first first lecture in algorithms. All right, so we are very excited to announce at CorioWood that we're starting this series of algorithms. We're gonna see what algorithms is, what it means, why there is algorithms, and how we're gonna use algorithms. All right, so we begin with our topic of algorithm, which is very exciting nowadays. I think in every university, in everywhere you guys gonna go, if you guys don't know algorithm, then it's very hard for you guys. All right, so we begin with algorithms. Why algorithms? All right, so you guys hear this word algorithm nowadays. Every now and then, you guys look at the Facebook, our Twitter, our Apple, our say Google, our Microsoft, our any other computer programs that some people they get scared. They hear the name of algorithms. They say, "My God, what is this? Is it mathematics or is it algebra?" It sounds like algebra. Yes, it sounds like algebra because the guy who invented algebra is attributed to this guy is Khwarizmi. So I'm gonna show you guys in the future videos who invented algebra. Okay, so algorithms are everywhere in our daily lives and are widely used around the world. From NASA Mars rovers to international space stations and airports use them to program flight paths. Yes, it is. Are exactly in our DNA. This whole universe, I think, works on algorithms. So, what the simple terms? You guys wake up in the morning. You guys going to have a shower. You guys wash your face, and you guys go and get prepared. Either you guys want to go to school or college, university, going to work, or for any reason. But you guys need to go and sit and you drink your coffee, and you guys go and prepare. You wear your shoes. You sit in your cars, or you go walk to work, and whatever for whatever reasons you guys want to take a bus. Sometimes you guys want to take train station, and you guys this is algorithm because you guys doing this in a stepwise. So you guys wake up in the morning, you guys just don't go wear your shoes, and unless you guys running late, but you guys don't wear your shoes before you wake up. It's impossible because you guys needs to do in order wise. Even if you guys want to go to work, so what you guys do, you guys want to come from airport to say home. The first step is that you guys thinking of getting a taxi, easier way taxi, and I'm going to go that this is the first and easy step. And the second step, you guys want to save some money, and you guys sit in a local bus, and you guys coming all the way to train stations, and from the train station you guys coming all the way to your suburb, whatever city you guys living, and from there you guys getting. So you guys doing this algorithm 3-step wise. And another way is that you guys call your friends or brothers, or you guys call your relatives which are waiting for you guys, and you guys going. So there are 3 ways that you guys are going to do the algorithm, whichever fastest. So we're gonna look at the running time for algorithms. So we're gonna say as I said here, algorithms are everywhere in our daily lives and widely used around the world. NASA Mars rover, and it's in fact Mars rovers. So Chinese Mars rover, they all have algorithm inside it. They are stepwise. Which algorithm is fastest? That's the topic, and that's what we're going to discuss with you guys. The running time of the algorithm. Which algorithm is the fastest? Say Google's search engines have the best algorithms of page ranking, and it beat every other search engines. So at the time, if you guys know that Green Page 98, that's page rank algorithms which are kept secret by Google, by these 2 guys who invented Google. And this is algorithm that everyone's after. Whoever wants to do search engine information retrieval are after this algorithm. So if they find this Green Page 98 page rank, they're gonna create exactly like that page rank, and they might beat Google. Facebooks have algorithms. TikTok, every big programming, complex programming guys see they have algorithms inside it, and with that help of that algorithm, they go on, they go and look at for the users, and they maximize their revenue. All right, so international space stations, everything's have a stage. We create algorithms to go to solve the complex tasks. So for example, the task that's is very hard to break, or very hard to understand, or very hard to control, we divide it into many small parts, and that's the topic of our divide and conquer, which I'm going to tell you guys in the future videos. What is divide and conquer, how we're going to divide. This is the And I'm going to show you this is a method used by British, by the English around the world to go and divide the people of that land, and they made sure that people don't like each other. And as nowadays you're going to see that in different country by Americans, they come into country, they divide the people into many sections, and when they divide in many sections, they're going to divide then they're going to control. This is divide and conquer, and this is actually algorithms. You guys see that in action around the world. But politics aside, algorithms, the basic of understand the basic of algorithm are essential for doing any work in the field of computer science, because we are a computer scientist and we were very interested in doing computers. That's what we know. We want to see the algorithms. We want to learn the algorithms to our to enhance our knowledge of in the field of computer science. Alright, as I said to you guys, search engine, which is Google, Yandex, and Baidu, Yahoo, and Bing, they all use algorithms, routing and communications. They all use algorithms. Public key cryptography relies on algorithms. And if you don't know, public key cryptography is like hashing. If you guys hash the password, or you guys, the banking uses this one, algorithms. All the bankings, the MasterCard, Visa, all these big institutions, they use public key cryptography. And the guys that the computer scientists are responsible for this cryptography, they do it that they bring every now and then, they bring very complex algorithms to, it's very hard for the hackers and for the people who steals money or try to decrypt these algorithms. They want to make their work very hard. And I'm going to tell you guys, the banking which they use cryptography algorithm is very hard. So you guys, if you guys want to break, the chances of the breaking this cryptography is like going there entire the universe and finding one atom is in the entire the universe. So that's how they make this hashing, and cryptography is very difficult. So the algorithm inside these ones are scary, I'm telling you guys. Database in indices relies on balanced search tree data structure. So that's what another one data. So the database indices relies on balanced search tree data structures, and we're going to discuss this one in our future videos, and we're going to go step by step in this one, balanced search tree data structure, what it is and how we're going to do this. Alright, so computational biology uses dynamic programming algorithms. So dynamic programming algorithm is dynamic programming is actually sort of algorithms. This is a topic inside the algorithm. So we're going to say what is dynamic programming, and in the algorithms in our videos. So computational biology uses dynamic programming algorithms to measure genome similarity. So if you guys, it might looks very odd to you guys. You guys say computational biology. What the biology has got to do with the computer programming? Yes, with the help of machine learning. Nowadays, hospitals around the world, doctors around the world, professors, and everyone relies on computer algorithms to measure genome similarity, to sequence the DNA. So this is done with the help of machine learning. With the machine learning, you guys can go and say that if the cancer is benign, or if the cancer is if the patient's got a cancer or the patient doesn't have a cancer. So with the help of machine learning machines, when they feed the data inside the machines tells you guys the million patients inside, and machine is going to tell that if the patients are highly unlikely that are going to have a cancer in the future. So this is done with the help of algorithms, and they uses dynamic programming, and we're going to discuss that dynamic programming in our future videos. Okay, algorithms play a key role in modern technology innovation. For example, search engine uses algorithm to efficiently compute the relevance of various web pages to a given search query. As I said before, the five main search engines, that's a Google, and there is a Yandex, there is a Baidu, and there is a Bing, and there is a DuckDuckGo, and I'm gonna put it here: Google, Yandex, Baidu, Bing, and DDG. DuckDuckGo is their biggest search engines. So Google is the first, Yandex is Russian, Baidu is Chinese, Bing is Microsoft, and DuckDuckGo is a very privacy oriented. It doesn't track you or anything, but it's a very popular search engine. So Google, Yandex, Baidu, Bing, and DuckDuckGo uses algorithm to give you best search results. They all use algorithms, and in the field of information retrieval and computer science, they all use the complex algorithms, and making search engines is very, very hard. You guys need to know complete algorithms to make search engines, and we're going to go one by one, and we're going to see how we're going to create a search engine with the help of algorithms, and I'm going to explain to you guys the different parts of the search engine. So the Google, Yandex, Baidu, Bing, and DDG uses algorithm to give you best search results, all the relevant search results. So this is search result. Well, what about the TikTok, Twitter, WeChat, Facebook uses algorithm to maximize their user and posts. So the TikTok guys there at TikTok, they use algorithm. Twitter guys use algorithm. WeChat in China and Facebook in America, they all use the algorithm. So the users comes in their website and spend the most time. So the TikTok brings you a profile, and according to that profile, they feed you guys the video which video you guys like, which video guys you spend the most time, which videos you guys share with your friends and family, and feeds you guys exactly the same videos. And that's same with the Twitter makes your profile what you like, which one, who you follow, or which post you guys like. So it's gonna feed you guys exactly the same as WeChat is the same in China, and Facebook is the same, and all of these website uses algorithm to maximize their users, for you guys to spend most of your time or to their websites and do your post. Whatever post you guys do, you guys might be doing any post, but for them this post is like making money. So you guys at the same time, they run you guys revenue, as with these guys here at the Facebook, they just send you data or whatever. They go there, any higher bidder for your data, they just go behind the scenes and sell your data. Alright, so even YouTube uses algorithms to give you your favorite video and run ads. If you guys look inside the YouTube, if you guys click on one video you like, and you guys see that your personal profile is there, algorithms there to learn about you and give you ads according to your watching videos. So if you guys skip one ad, the same ads gonna come in, and that's how they maximize their revenue. And inside all of the above, there is a complex algorithm. So algorithms are everywhere nowadays. You guys see more and more in computer science, in different websites. This is just a few websites that uses algorithms, and we're going to see what is algorithms, and we're going to go step by step, and we're going to learn all this about the hashing algorithms, about the public key cryptography. We're going to see about the dynamic programming algorithms, and we're going to see about the genome, and we're going to see the different. But as I said before, algorithms are everywhere. You guys do that everywhere inside our body, inside our DNA. So the whole universe runs on algorithms. So algorithms are everywhere, just like a day and night. And you guys, different days, the winter comes in and the summer comes in, but before the day is 24 hours. So everything happens in algorithms. The waves inside the ocean, if you guys look at the power of the universe, the light travels, everything happens with algorithms. So there is complex algorithms happening around the world. And if you guys, we do that algorithms every day. So we count, say in mathematics you go 1 plus 1, that's algorithms. So if you guys going advancing 1 minus 1, or you guys use that plus sign just like a cross, you guys say that's algorithms. You guys put it on top of each other, that's also a way of algorithm. So even you guys learning algebra, you guys put an x, you guys put it beside it, and that's also actually multiplication. And you guys can put just a cross sign and put it the other way around, that's your multiplication. But if you guys put a dot, that's also multiplication, that's also algorithm. This is a way of doing one thing simpler. So in algorithm, we're going to see how we're going to simplify things and how we're going to solve the problem. And there are different methods of solving the problem. And in algorithms, we're going to see the worst case, the running time, the worst case. And because that's the worst case running time, it means how long it, say a computer you guys buying from the shop, and you guys sitting in front of the computer, you guys turn on the computer, you're sitting 15 minutes. That's pathetic. 15 minutes in front of the computer sitting, and the computer is not even loading. This is called the worst case running time. In algorithm, we're always looking for the worst case. We are not looking for the best case or average case. Average case or okay, but the best case is like a very ambiguity inside. We don't believe in there is no such thing as a best case. We also always looking for the worst case. So just remember, in algorithms we're always looking for the worst case. So if you guys loading Google and you're looking at the Google on side there, how long it took for the Google to search your brought your all this your search. So that's the worst case for the Google try to say make your their search engine as fast as possible to make your to bring you relevant query as fast as possible. So it happens in a milliseconds. And also Google likes to rank their websites, the fastest websites, on the top of their ranking list. So that's what the Google search engine algorithm is. So the Google likes to make the website as fast as possible, and whatever is YouTube, the loading time is going to be very, very fast. If the YouTube takes too long, then the Google notify you guys, either you guys having a problem with your network, or you guys having a problem with your internet. So all in all, Google likes to give you guys the fast, because users tend to leave the website which is loading very slow. You guys know that the website came in 85 90s, and at that time the Alibaba came in, and this Jack Ma went there and tried to load the China pages in their website, and it took like 6 hours. That's in that days that was okay, because that was the computer just came in, and the worst case was very tolerable for people. Even if six hours to load one page was accepted at that time, is like 90s and 85s, because the internet just arrived. But nowadays, if the website takes like 5 minutes, you guys gonna leave. I guarantee you guys gonna leave the website, and you guys gonna don't like the website. You gonna never gonna revisit that website again, even if you guys if you guys say really desperate to see that website, because you guys not gonna wait for you 5 minutes for one website to load, even 1 minute for one website. So you guys expecting a website to load in a matter of milliseconds, if not millisecond, at least seconds. So that's what the standard nowadays. So that's what algorithms, we say that the worst case times, we always go for the worst case, how long it takes for one machine or one website to load, to works. So that's what is the reason people like Androids, for example, because Android's Linux, and the load time is very quick compared to Windows, because Windows taking long and long and long. And I know nowadays that the Windows guys are trying to minimize that one. They're working on this one, so you guys soon you're gonna see the future version of the Windows is gonna be loading very quickly, just like Linux and just like Apple. So this is the first video of algorithms, and we're gonna go slowly bit by bit, and I'm gonna show you guys why we study algorithm, how we study what is algorithm, what's the different time, what is big O, what is omega, what is theta, and what is the running time, what is the worst case running time, the best case, average case, and we're gonna see all these algorithms, and we're going to study this algorithm. So this is, I again welcome you guys for the first video in our study with algorithms. Alright guys, that's it for this video, and I'll see you guys in the next video, and bye.